Hi guys, my name is Peter. I just wanted to create this quick video to go through one of these key parts that's related to your assignment. So I've just got the assignment sheet here in front of me. I'm going to be doing part 2, question 1. So in this part, we're going to be calculating the CAPM. And to do that, you're going to need 3 key variables: the beta, the risk-free rate, and your risk premium. So the latter two can easily be gleaned off information and resources, and we'll do that a bit later. But I just want to focus mostly on this video on estimating this beta. So let's go to the relevant slide first. So to estimate beta, there's actually 2 approaches. So first approach, we can just use this formula, and we'll do that a bit later. The second approach is this regression approach. So the regression approach is basically just based on this simple regression here, where R represents your returns on your security. This will be your Y variable, and RM, this is your X variable, will be related to your returns on your market. Okay, so to calculate beta, we need those 2 sort of measures first. So returns on our security and returns on our market. Okay, so let's go back to our Excel sheet and see if we can calculate that. So here we've got our time series data from 2013 all the way to, from memory, let's have a look here, to the start of 2018. And here we've got price data related to Flight Centre, and we've also got data related to our market proxy. In this case, it's our ASX 200. So let's calculate returns, shall we? So we're going to make a heading here. R for, let's say, our Flight Centre is going to be equals as follows. Okay, I'm going to notice here I'm starting on the second cell here, the second period. I'm going to press this as equals LN. So I'm going to open this bracket. It's going to be equals to our price today. Let's say it's 32.29 divided by our price yesterday, 31.92. And I'm just going to press equals, and there's our return related to our periods. So you can do that one by one for every day all the way to the, to the beginning of 2018. That would obviously take a little bit of time. Or you can just use some Excel shortcut. So if you notice that there's this black box here, I can just double click that, and that should drag down the formulas all the way to the end. If that didn't work for you, then you just sort of click that using your left hand, I don't know, what do you call it? Your button on your mouse, on your left hand, on the left hand, they say there's left and right. Anyways, you're going to press that, and you're just going to hold it down and bring it all the way to the bottom. And that too will also work. Okay, you don't want to make the assumption that that formula was dragged correctly, so I'll just double click on one of them and just see how the formula sort of was dragged down. You can see here it was dragged down correctly because this return is based on that today's price divided by yesterday's price. And you can see here, for example, 0 returns. What does that mean? It means today's price was the same as yesterday's price, hence 0% returns. And you can keep them going down here. Let's go to maybe the latter part of this data. We can see that was also dragged down correctly. Okay, so that's our returns related to our Flight Centre. We're also going to do the same for the returns related to the market. So again, I'm going to make a new heading first. So returns for the market, this is the ASX 200. Okay, so again, starting at the second period, it's going to be equals to LN, open your bracket, today's price divided by yesterday's price. Okay. Then I'm just going to drag that down, and I'm pretty confident that was done correctly. But again, just go through it and just make sure things are done correctly. Okay. So using those 2 variables now, returns on your Flight Centre and returns on your market, you're now going to be generating this regression model. Okay. So to do that, we're going to need a function under data known as data analysis. But if you don't actually have this, I'll be going to File, Options, Add-ins, Analysis Toolpack, and then I'm just going to press Go. And then make sure this is clicked here besides Analysis Toolpack. I'm then going to press OK. And if that worked properly, you should have a Data Analysis tab that appears here now, just under that Data General tab here. Okay, so I'm going to click Data Analysis, and it's going to give you a few options you can use as a tool. We're just going to go down to Regression, and I'm just going to press OK. So I'll just delete these numbers here. I've done it just beforehand. Okay, so it's pretty intuitive here. Here we're going to input your Y range. So recall from that slide, we made Y to be the returns related to the security. Let's do a refresher. So here Y is the returns to your security, X is your returns related to your market, your ASX 200. So going back to here, our Y range would be related to our returns on the security. I'm going to highlight all the numbers here related to the returns of my security. Done. Then I'm going to click on this box. Here I want to highlight the returns related to my X range. In that case, it's related to my returns to the market. So again, doing the same thing, highlighting all that. And that's the returns related to my market. Okay. The next job here, I want to sort of highlight or indicate where they're going to just drop this output related to my regression. So I just want to drop it within the sheet here. So I'm going to go into this, make sure that your mouse is clicked in that box. Otherwise you might stuff up these numbers up here. And I might just select one of these cells here. And then that will just, oh, that doesn't work. Oh, here it is. Sorry. Output range. So in your output range, just maybe select an area here, and that will just dump that output somewhere around here. Okay. I'm going to press OK, and there's our output for our regression. So where is this magical beta? This magical beta is this highlighted number that I've got here, but let's make it more clearer for us. Beta is equal to that number. Okay, so you may recall in topic 3, if I go to topic 3 here, that, you know, in certain cases, we may want to adjust our beta, right? So that would be slide 41. Okay, so because beta tends to be mean reverting, we want to sort of adjust our beta. So how do we do that? We can just use the following formula. So it will be our raw beta. That's what we just calculated there, multiplied by 0.67 plus basically just 0.33. So let's go ahead and do that. So our raw beta, so let's adjust the beta here, will be equal to our raw beta multiplied by 0.67 plus 0.33. And there's our adjusted beta. Okay. So that's one approach to calculate beta. I'm now going to go through quickly the second approach. The second approach is we're going to be using, again, just doing a bit of a refresher, going back to our slide before, just using that covariance over our sigma square formula. So let's generate both these numbers. So we need the covariance related to our returns on security and our returns on the market. Okay, so let's do that. So we want to calculate some sort of covariance formula or number, which is going to be equals to, just made a heading there, covariance. So we're going to select dot s as a function, s representing our sample, and we are dealing with sample data here, so it's the appropriate one to use. But you know, it's not going to make a huge difference even if you use the dot p. Okay. So array 1 would be our returns related to our security. This would be Flight Centre. So again, just highlighting all those returns. And I'm going to go comma. And then array 2 would be our returns related to our market, our ASX 200. Okay. And then you can just close that bracket and press enter. There's our covariance number. Let's now calculate this other number, our sigma. Let's just calculate sigma, our standard deviation, and then we'll square it a bit later. Okay, so I want to calculate basically my standard deviation, std ev.s, there it is. And then again, number 1, and then number 2, and so on. So that means I'm just going to highlight all my numbers I want to, that's, I guess, underlying this standard deviation calculation. So that would be just going back to your slide here. I want to calculate the standard deviation related to your market returns. So there's my standard deviation related to my market returns, or these numbers here. I'm just highlighting that. Going down, and I'm pressing enter. Okay, there's our standard deviation related to our market return. So how do we calculate beta? Well, we know beta is going to be equal to, just refreshing the formula again, covariance divided by our standard deviation square. So let's do that. It will be our covariance divided by our standard deviation square. And hopefully, and it does, this number is equal to our adjusted raw beta, or not adjusted, our raw beta, I should say, that's over here. It's just differences in rounding. So you can move that up or down depending on what suits you. Okay. You can adjust that too, but I'll let you guys do that. It's pretty much the same thing. Multiply your raw beta by 0.67 plus your 0.33. Okay. Now let's go ahead and see if we can calculate CAPM. Let's just make a new heading. Okay, CAPM. So to calculate CAPM, recall that we're going to need 3 key variables. We're going to need our risk-free rate. Here we're going to be using the risk-free rate of, if you look at your assignment, it's your 10-year government bond yield, right? So I'm just using a 10-year government bond yield. I've had a look at it some time ago, and I think from memory, and I just picked a date sometime I can't remember exactly, but it was 2.69. It really depends on what date you use, but you should probably get something similar to that anyways. But do let me know what date you used. We also need a risk premium, right? So we can calculate risk premium. We can do it here. So recall, what does risk premium equal to? Well, risk premium, recall it was equal to our expected returns on the market less our risk-free rate. Okay, so let's calculate our risk premium. Our expected returns on the market, that is given to you. So if you have a look at this assignment, it says here, we have provided a expected risk market return of 9.826. So that's your 9.826 less our risk-free rate of 2.69. Okay, there's our risk premium. Let's calculate CAPM now. So CAPM is going to be equal to, and let's show you the relevant formula. I'm going to go to topic 3 again, and we want to go to slide 30 here. Okay, so CAPM is basically going to be equal to your risk-free rate plus your beta multiplied by your risk premium. And that risk premium we've already calculated, being just the difference between your expected returns on the market less your risk-free rate. Okay, so let's do that. So it'll be your risk-free rate, 2.69, plus your beta, your adjusted beta in this case, of 0.928, multiplied by your risk premium of this number here. And there's our CAPM number. So this is in percentage. This would be 9.31%. If you use the risk-free, I mean, I've used numbers in percentage, but if you, for example, use the risk-free rate of 0.0269 here, then this risk premium would also need to be adjusted as a decimal. So, it'll be 0.0713 and so on and so on. And then here, of course, that would not be 9.31. This would be also expressed as a decimal. But, that's up to the design of how you input in these numbers. Okay. What's next here? That's basically part 2, question 1, that hopefully, you can do now. The next part here, we need to calculate the DDM model and the free cash flow to equity model. So I'm going to save those parts for the next video that's coming up. Hopefully that was useful. If you have any questions, do post it up, in the discussion page somewhere. I'll catch you guys next time. See ya.